Okay, so yes, we were discussing energy stored in a capacitor. We were driving the equation. So yes, here we have the first equation: volt is equal to work per unit charge. We want to separate this work. We need to find this. So we multiply this value. We found this equation. Then here, this is the average potential energy. The way to find that is this one, which I discussed in the last video. Then here we have the average. From here, let me discuss it again. So yes, here this is the average velocity VAV, final velocity minus it would be initial velocity, and which would be divided by 2. Okay, so we can also write that the average velocity which is equal to VF upon 2, and I'm sure you also know that. Okay, then here we have VAV. We can also write this as a VAV is equal to V upon 2, just because we do write final and initial when we have the two, like volt or two, any equation you find two, that's why we give name as a V1 or M1 M2. So here we have only one file to write F, so this equation become V is equal to mm, wait, okay, uh, average velocity become equal to V upon 2. So this equation becomes the first equation here, which will be used in the video, like in the downward, like, oh god, I forgot to erase these. Okay, so let me just do that. Okay, so yes, till this we are done, and here we know wherever I just write u word, u simply tells the u tells the energy, so work or energy. So here then we have the term which is w, which is which is equal to v upon q. Okay, then we know that if work is w, so energy is u, or work is also known as u, so we write this as equal to v upon q upon 2, just because we put this in the equation upon 2. Then u is equal to v upon 2, uh, v upon q is the same. U here the charge, and here I have written another v, if I'm not wrong. Let me just, so here is a q, which is q charge, because we have the 2q here. We have placed this accordingly. Okay, then what will happen, this will become the second equation. Okay, second equation. Then we know that the charge q here is also equal to C capacitor per volt, volt. This will become the second equation. Okay, then we know that the V is equal to 1 upon 2. Here we will see V, like we are combining this equation. V is equal to 1 upon, this is 1, sorry, this is 1. Let me just erase it. Sorry, this is 1. So 1 upon 2, this is the V, CV, this one, just because wherever you see the Q chart, you have to write this. And like I have just written Q, Q value is this one, this is also Q. So wherever you see the word Q, you will write CV, and this V is already present, so I've just written like that. Okay, then what would be another step? If we have the 2V, you can also multiply them. So V is equal to 1 upon 2 CV square, and this is the, like the equation we got in the term of capacitor and voltage, where whenever you get the capacitor and voltage to find the charge, and this is in terms of capacitor and voltage. And we have the second equation, which is 1 upon 2. Wait, let me just, so the upper equation when you get capacitor and the volt, and downward if you don't get the charge and